And now it's go to 4 to 6 is for log graph. You see two log graphs. One is hx is the blue one. One is log 0.5x is this one. So this one, the base is 0.5 is less than 1. It's between 0 and 1. So you see it's this shape. And this one is 2, so you see in this shape. Not touching the y-axis, not going this side. And I show you this one first. And if this one is increasing, you see this one is going down. And I'll show you one more graph. So this will be this 2, base 2, is base 3. You see base 2 is higher, but this one is lower when x is smaller than 1. And this one is lower and this is higher. So you see the pattern is going down from higher to lower. It's this side. In this side. When this is both of them are smaller than 1, from between 0 and 1, for example, this one is 0.8, this one is 0.2, for example, you see the case is different. 0.2, 0.4, this 0.8. 0.4 is in this direction, 0.8 is this direction. It's higher, this lower. So you see this going to this side, from lower to higher. And when it tends to 1, it will come like a straight line, x to 1. When it comes higher, it will go in this side. So the tendency is from this side, going to this side, in clockwise direction. So you can note the pattern and you can memorize it for your reference. And there's also reflection symmetry. If this one is 2, for example, if this one is 0.5, you see this reflection of the y to 0 x-axis. It's reflect on the y to 0. Okay, and I'll show you why. And let's compare log x base 2 and log x with base 1/2. And you can rewrite this one as this, log x over log half. And 1/2 you can express as 2 to the power -1, and move the negative 1 to here, and that means it's negative to the whole expression. And this one can convert it back to log x with base 2, and you compare this and this. This is just this is the same, and with just this one is negative. So if the value of this whole thing is 2, the whole thing of here is -2. So the graph will be like reflection of the x-axis. So the y value will change. So if the value is 1, 2, the other will 1, -2. Okay. Now I show two graphs. One is exponential graph, is one log graph. They are with same base. You will see they are a kind of reflection from the y to x-axis. And if this is a 2 point, this is a 0.42. This point will come 2, 4. The x and y, the xy coordinates are interchanged. And if I change this line bar, for example to 3, right here, you will see there are also reflection and the xy direction is changing. And if a is from 0 to 1, 1 is like this, 0 points. There are also reflection of this direction, but this graph is here, this graph is here. Reflection of this side. A bit difficult to draw. This part reflect this line to here. This part reflect this line to this. Okay, so the shape is a bit different when x is from 0 to 1. Also reflection, but the shape is not as easy to see. When x is to 1 point something is like this. When greater than 1.5, it is more easy to draw. So you see this quadrant always have no solution because there's no thing with x and y also negative values. And this is the last part. And I will also show you why using like algebraic method. Uh, at last, we compare these two. These two also reflectional symmetry upon the x to y. The line you see, this one is y to the power x. This one is y to log x with base 2. But y log and the exponential can exchange each other, because log x to the power 2 and y as 2 pi to the power y to x exponentially. So if you compare, this one is 2 pi x to y. These two just interchange upon the x and y. So x and y, the value changes. So for example, one is 2, 4, the other is 4, 2. So you will see it is like reflectional upon the x to y axis.